Today we're going to learn about solving inequalities containing and. Two inequalities form a compound inequality where the intersection is the solution. When you have an and between two inequalities, then the solution set is only what's included in both of them. So in the first example, we can see this very clearly. We have x is greater than or equals to 0, and we also have x is less than or equals to 2. So we're going to have two closed circles, and we're going to draw a line connecting them. So this interval is the solution set. 0, 1, and 2 are solutions to this first problem. We're going to call problem 1a, problem 2b, and problem 3c. B is a little more complicated because we don't have the and clearly explaining what the two inequalities are, but the inequalities are going to be negative 2 is less than or equals to y minus 3, and y minus 3 is less than 4. So these are going to be our two inequalities here. Now we want to isolate for y. We're going to add 3 to both sides of the first one. We're going to get 1 is less than or equals to y. And for the second one, we're going to add 3 to both sides as well. And we're going to get y is less than 7. So we're going to have a closed circle at 1. And we're going to have an open circle at 7, because it doesn't include 7. So it has to be less than 7, but greater than 1. So the interval is going to be from 1 to 7. For this last problem here, we have negative 6 is less than 3 minus z, which is greater than or equals to 12. So we're going to separate this into our two equations, which are going to look like this. Remember, for both equations, you always include the middle value in both, but one equation includes the number to the left of one of the inequalities and the other includes the one on the right. So now we're going to subtract 3 to both sides for the left equation, and we're going to get negative 9 is less than negative z. And for the right one, we're going to also subtract 3 to both sides. So we're going to get negative z is greater than or equals to 9. For the left-hand one here, we're going to divide by negative 1. And the inequality is going to flip, so it's going to be 9 is greater than z. And for the one on the right, we're going to also divide by negative 1. And the inequality is going to flip as well. And we're going to get z is less than or equals to negative 9. Now this is an interesting case because we have to have a value of z which is less than 9. So first we're going to put an open circle on 9. But then the value of z also has to be less than negative 9. And this is going to be a closed circle. Now because all of the values from negative 9 to 9 are not less than negative 9, then we actually invalidate all of them. The point at 9 is going to now be deleted, and we're only going to pay attention to the values that are less than negative 9. These are the only ones that both equations share in common. So this is going to be b, the interval from negative 9 to negative infinity, and that's going to be c.